As we consider planets in other solar systems, we need to think about one more thing: the types of stars that the planets orbit. The variation among stars is even more profound than the size differences between planets that we've already discussed. So I'd like you to take a few minutes and view two video tutorials about stars. They're fun, quick summaries, and they include media that I wouldn't be able to fit in a PowerPoint. Besides, now's a great time for you to get a break from my voice and hear someone else talk. As you look at the videos, watch for these important star-related ideas that affect our search for life in the universe. In fact, I suggest you take a quick listen before the video to what I'm about to say before the videos, then maybe come back and review them again afterwards, because this is quite a lot in such a short time and it kind of goes by rather quickly. So first, mass is the determining parameter. This is because mass causes gravity, which compresses the interior of a star, creating the conditions for the nuclear reactions that make stars shine. The smallest stars are only about 1/10 the mass of our sun, just big enough to generate nuclear energy. The smallest stars have a surface temperature of a few thousand degrees, about half the temperature of our sun, so a planet must orbit closer than our Earth does around the sun for Earth-like heating. The biggest stars are 100 solar masses, so big that the energy they generate almost blows them apart. They have surface temperatures at tens of thousands of degrees, and they fry their neighborhood with so much radiation that any planets around them would be sterilized. Second, low mass stars live much longer than high mass stars. The smallest stars will last for trillions of years, which is far longer than the age of the universe so far, while the big ones will last only millions. Notice that first one was trillions with a T, and this is only millions with an M. Comparatively, that's just the blink of an eye. Our sun's lifespan will be in the middle, about 10 billion total years, and that's billion with a B. And we're now near the midpoint of that 10 billion year lifespan. Since we are interested here in stars that might be long-term stable hosts for planetary systems, we can ignore star birth and stars' exotic end stages, focusing instead on their stable middle age or main sequence lives. So the third thing is that the smallest stars, the lowest mass stars, are overwhelmingly more common. That means we're very interested in whether they might host habitable planets, because if they did, that would be a lot of places. Planets might have to be very close in to these smaller, cooler stars to be at a habitable temperature. Okay, those are three ideas to look for. Now go view those two videos. The first one is an animation with terrific explanation. It's done by Kurzgesagt. The second one is a star size comparison. It doesn't have much explanation, but while the first one has cartoon-like pictures, this one really has great pictures, actual real astronomical imagery for some of the closer objects, and really nice artist conceptions for the more distant objects for which we don't really have high resolution images. Don't worry about these long, messy URLs here. I will put both of the URLs in the description for your easy clicking. So go ahead, watch the videos, enjoy.